Hello. Hello, everyone. Okay, so today I'm getting a bit sick, so I hope I can manage till the end of the session. So I hope you're enjoying half term. Those of you who are on half term, and yeah, kudos for joining today. Let's we're doing maths today, and we're continuing with equations. So I've got some equations for you. They are different relevance. So some of them are very relevant to what you're doing. Some of them are less relevant, but I hope it will be interesting for you today. Most of the questions today are done using graphs. And this is one of the crucial things about equations, that all equations can be done using graphs, which is quite cool. All right, so problem one. I'm assuming everybody can hear me and see my screen. If not, let me know. Okay, lovely, thank you. How many solutions does the equation have depending on A? Well, you can notice that if we take A to the other side, so method one, let's call it method one, discriminant. So you can write the equation x squared minus 4x minus a equals 0, and find the discriminant. Discriminant of the equation, of the quadratic equation, is b squared minus 4ac. So in this case, it is b squared, which is minus 4 squared, minus 4 multiplied by a, which is 1, multiplied by c, which is minus a. So it is 16 plus 4a. And we know that if the discriminant is so Dania, if you are in year 11, it's the second to last one. If you're in year 11, you have 6 assignments. If you're in year 10, you have 10 assignments. Okay, so no, it's not the last one. You have one more if you're in year 11, and you have 5 more if you're in year 10. Okay, so, and then, well, you know that if discriminant is greater than 0, there's 2 solutions. If discriminant is equal to 0, just one sec. Okay. Right. Yes. Sorry. No, I'm back. I had to. All right. Okay. So, like, if discriminant is 0, there's one solution, and if discriminant is less than 0, there's no solutions. Okay. And if discriminant is greater than 0, and that means 16 plus 4a is greater than 0. That means 4a is greater than minus 16. And that means a is greater than minus 4. So if a is greater than minus 4, there's two solutions. And if a equals minus 4, there's one solution. And if a is less than negative 4, there is no solutions. So one solution. Okay. Okay. Right, you should be able to hear me still. Sorry. A different method, you can do you can do the same problem if you say, okay, second is the graphical method. Graphical method. And so here what you do is you draw two graphs. Draw two graphs. You draw y1 equals x squared minus 4x, and y2 is equal to a. So you draw the left-hand side and the right-hand side as separate graphs. And then you sketch them. Oh, sorry, well obviously, you draw the two graphs. So, yeah, x squared minus 4x is a graph like this. So it goes through 0, and it goes through 4, and it has a vertex at minus 4. So bam, bam, bam. So the graph looks like this. This is y equals x squared minus 4x. Now the second graph is y equals a. This is a horizontal line. Y equals a. Y equals a. Y equals a. Depending on a, it's like a quadratic inequality. Well, it's not really a quadratic inequality. Y equals a. So like y equals, so this in particular, this is y equals minus 6. So this is y equals minus 6. Or basically a equals minus 6. Then this would be y equals minus 5, y equals minus 4, y equals minus 3, y equals minus 2, y equals minus 1, y equals 0, y equals 1, etc. So y equals a is a horizontal line depending on what a is. So y equals -6, y equals -5, y equals -4. And you can see that for y equals -4, there's one point of intersection. So if y is equal to -4, there's one intersection. If y is less than -4, there's 0 intersections. That means 0 solutions. And if y is greater than -4, it is 2 intersections. You can see for any value of y, basically what we're doing here is we are moving this line like this. So this is y equals a for different values of a. So if a is less than -4, it's here. There's no intersection. One intersection, two intersection, 2, 2, 2, 2. So for any value above -4, it's going to be 2 intersections. Does that make sense? Do you understand? Do you understand what I've done? All right. I'd like 7 answers, please. I'd like everyone to reply. So that's 4. Okay, so 3 people haven't replied. Okay, 2 people haven't replied. Dennis, do you understand what I did? I'll start picking on people. And Mark. Dennis and Mark, do you understand? Okay. Might not be able to hear me. Anyways, I can do the same thing here. I can do the same thing here. I wonder, it would be quite interesting. Sorry, going off topic. What if I ask ChatGPT, how many solutions does the equation x squared minus 4x equals a have depending on a? Let's see if it gives us something. Ooh. Quite cool. Quite cool. So it did give us the correct. It's getting better. It's getting better. All right. So this is ChatGPT. Anyways, if you draw the curve, so y equals x squared minus 4x and y equals a. We can change a, and as you can see, this is the graph, this is the other graph. So if we change a, the graph goes like this. Okay. Now slightly harder. We go a step further. How many solutions does the equation have depending on a? And now we have modulus x here. Modulus x. So what does that mean? Well, we remember that modulus x is equal to x if x is positive, and it's equal to minus x if x is negative. So in order to draw this graph from here, y is going to be equal to x squared minus 4x, the same graph as before, but this is only if x is greater or equal to 0. And if x is less than 0, then it will be y equals x squared plus 4x. Oh, here. This is the answer. Sorry. How many solutions does it have? So if a is equal to -4, it's one solution. If it's less than -4, it's no solutions. If it's greater than -4. Okay. Now the equation becomes, so if x is negative, it's going to be this graph. So we're trying to draw the left-hand side as a graph. So how does that work? Okay. So x squared minus 4x. So if x is greater than 0, that means if x is positive. So if x is positive, the graph matches the previous graph that we had. So remember, it starts from here, it goes here, goes here, and it goes here, etc. So and now if x is negative, it matches this graph. And this graph looks like this. So how did I do that? Just a quick recap. So I had a graph of y equals x squared minus 4 modulus x. And we know that this thing is equal to x squared minus 4x if x is positive, and it's equal to x squared plus 4x if x is negative. This comes just from the definition of the modulus. Therefore, for x greater than 0 and for x is less than 0, I draw two different graphs. Do you understand? Do you get it? And on a scale of 0 to 10, please. Okay, that is a very good thing. That is a very good thing that you've said. Okay, let me let me just go through that once more. So by definition, sorry, I'm honestly, my head is really fuzzy. I think I'm getting sick. So if it's okay. By definition, modulus x is equal to x if x is greater or equal to 0, and minus x if x is less than 0. So if you were to draw the graph, this means that x squared minus 4 modulus x is equal to, it's either equal to x squared minus 4x in case x is positive. If x is positive, it's that. Or it's equal to x squared plus 4x if x is negative. Up to here, how well do you understand on a scale of 0 to 10? Up to here, don't care about the graphs. You understand now? Okay. Now, the conclusion that if x is positive for positive x's, for x greater than 0, the graph matches y equals x squared minus 4x. And for negative x's, the graph matches y equals x squared plus 4x. So we draw both graphs. We draw both graphs and we say, okay, this is x, this is y. So the first graph is x squared minus 4x. That looks like this. Sorry. Bam, 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 bam. The graph looks like this. This is y equals x squared minus 4x. And the other graph looks like this. And this is the graph y equals x squared plus 4x. Now, if x is positive, it matches this graph. So we just draw over it for the positive x's. And if it's negative, it matches this graph. So we kind of switch to this graph. And that's why we have this weirdly shaped graph. The upside down McDonald's logo. Do you understand now? On a scale of 0 to 10? If you sketch this graph in Desmos, you just say y equals x squared minus 4 modulus x. Here it is. Here's the graph. And now y equals a. This is a horizontal line. So you can see that as the line moves. So what I'm going to do, so this is a equals minus 4, a equals 0, a is greater, like this. So this is a is less than 0, less than minus 4. This is A is equal to -4. This is A is between A is between -4 and 0. This is A equals 0. And this is A is greater than 0. Now here we have no solutions. No solutions. Here we have 2 solutions. Here we have 4 solutions. Here we have 3 solutions. And here we have 2 solutions. So the answer just a sec. Sorry, had to attend to a tutorial which is happening in a parallel. Okay, so the answer is that no solutions, 0 solutions, if A is less than -4. 1 solution if 1 solution if oh no, there's never 1 solution. 2 solutions. 2 solutions if A is greater than 0 or -4 less than A less than 0. 3 solutions if A is 0 and 4 solutions if okay equals -4 if A equals -4, 3 solutions if A equals 0, and 4 solutions if -4 less than A less than 0. Okay, I hope that makes sense. We're going to find the video for webinars on our YouTube. Here you go. All the webinars are here. And also on our website. On our website, you can find all the webinars. Well, the link to all the webinars. Okay. Any questions? Any questions about this problem? Okay. For which values of A do the two equations have at least one matching root? Well, what can we do here? Well, we can say, well, you can find the roots of the second one. It's quite easy. What are the roots? Do we know the roots? Okay. Yeah, we can find the roots. So for this equation, x1 is 2. Well, I'll use the Vieta's formula. Okay, x1 times x2 is equal to c over a, which is 6 over 2. 6 over 2, which is 3. And x1 plus x2 is equal to minus b over a, which is 7 over 2. So which two numbers, when multiplied, make 3, and when added, make 3.5? 3.5. When added, make 3.5, and when multiplied, make 3. Well, that's 2 and 1.5. So x1 is 2, yeah, and x2 is 1.5. Perfect. Lovely. And here you can express x1 and x2 in terms of a. So we can find the discriminant. Discriminant is b squared minus 4ac minus, so plus 8a. Okay, so x1 is minus b plus square root d over 2a, and that is minus b, so that's minus 1. Minus 1 plus square root of 1 plus 8a divided by 4. Okay, and x2 is very similar. X2 is that with a minus. With a minus. Now you can see that x2 is always negative, because this is a negative number, -1, and this is negative square root. So this is always less than 0. So this will never be equal to 2 or 1.5. This is always less than 0. And therefore, only this one can match. So which root can match? Sorry. Only the x1 can match. Does everyone understand what I'm talking about? Because x2 is negative and x1 can be equal to that. Okay, so now we need to solve. Only x1 can match. So -1 plus square root of 1 plus 8a divided by 4 equals 2, or -1 plus square root of 1 plus 8a over 4 equals minus 1.5. Right. You would think that this is a difficult equation. Actually, it's not. It's really not difficult. So all you need to multiply by 4, that's 8. Add 1, 9. So square root of 1 plus 8a equals 9. Because you multiply by 2, add 1. And then the square root of something is 9. That something is 81. So 1 plus 8a is 81. 8a is equal to 80. So a is 10. And secondly, I do the same thing, -1 plus square root of 1 plus 8a equals 6, plus 1, 7, square root of 1 plus 8a is 7. 1 plus 8a is 49. 8a is 48. A is 6. Okay. Let's check. Let's check that this is indeed true. So you draw the first graph, draw the second graph. And you can see that indeed the first graph, well, whichever, the second graph has roots 1.5 and 2. These are the two roots of the equation. Now the second graph has -a, and as a changes, it moves up and down. So at the moment it has no roots. It has matching roots only if it has the same x interval. And as you can see, the left-hand side root is always negative. No matter what you do, it's always negative. So you go bam, 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 and that's it. So when a equals 6, you can see that they have a matching root. So this happens when a is 6. And the next one is when a is 10. You can see that they have a matching root. So let's when a is 10 and when a is 6. Okay, so here repeat root. And this is when you don't need this. This is when a is 10. And here, this is when a is 6. This is the same root. Okay, I hope that's making sense. Next one is a very similar problem. For which values of A do the two equations have at least one matching root? But here you can see that both of them have both of them are A in them, so you can't really solve them. But let's see what can you do about it. So let's find x1. x1 for the first equation is minus b minus a plus square root of a squared minus 4 over 2. x2 is minus a minus square root of a squared minus 4 over 2. Okay. Here, x1, really don't like to give them the same name. Let's call it x1 star is equal to minus 1 plus square root of 1 minus 4a over 2. And x2 star is equal to minus 1 minus square root of 1 minus 4a over 2. You also need to notice that in order to have roots, this has to be positive. So comparing them directly, it's quite an arduous task, like trying to make them match. You can see that for this one, only has roots if 1 minus 4a is positive. That means 4a must be less than 1, so a must be less than or equal to a quarter. So it only has roots if a is less than or equal to a quarter. If a is more, then it doesn't have any roots. Okay. Now here, a squared has to be a squared less minus 4 has to be greater. A squared minus 4 has to be greater than 0. That means a squared has to be greater than 4. What can a be? What can a be if a squared is greater than 4? Only 2? I agree with 2. What about, I don't know, 3? Can a be 3? Can a be 5? Well, 5 squared is greater than 4, so yeah, it can be 5. Okay. There's a lot of things you can do here. Well, you can realize that, well, a has to be greater than 4, a squared. So it's either greater or equal to 2, or a is less than or equal minus 2. So it can be minus 5, for example, because minus 5 squared is greater than 4. Now this one isn't suitable because we already know that a is less than a quarter. So it can only be that. So we can only consider negative A's. We can only consider negative A's. What does that mean? That means that x1 is strictly positive. Listen, so you can okay, negative A's. So what if A is negative, this is positive, and this is positive. This one is, we don't know. Weird. Okay, you could do a lot of interesting things here, although it will get really complicated if you try to keep in your head, you're trying to keep A in what the possible values of A are. Okay, so lots and lots of things to consider here. That's why the algebraic method isn't really suitable here. Whereas the graphical method is way more simple. All you need to do is to draw the two graphs and see what happens to them as A changes. So let's start with the first graph, x squared plus ax plus 1. Here it is. It's a parabola. And look what happens as A changes. Okay, so you either have two positive roots or two negative roots. And the vertex kind of moves around a parabola. Okay. All right, so this is what happens with the first graph as now you draw the second one. Now the second one is very simple. It just moves up and down. So the question is, when do these two graphs have matching roots? And as you can see, for positive A's, it just doesn't work. It only works for negative A's. Okay, so let's draw both of them and see what happens to them as A changes. So positive A, there's no use, no use, no use, no use, no use, no use. Okay, so A is 2, A is 1. They don't have any roots. Bam, got it, found it. When A is minus 2, look at that. When A is minus 2, they have a matching root if A is minus 2. So you don't need these. Have these. A is minus 2. Now what happens as A decreases further? You can see that this root gets closer and closer to 0. You see, it gets closer and closer to 0. So, and the other root becomes larger and larger and larger. And you can obviously see that this root, the black one, increases faster than the red one. So they will never match up. The gap between them increases. So we start like this, and as we go further along, the gap between this and these roots, these two roots, increases. So they will not meet again. So these two curves will not meet at the x-axis, and therefore the only place where the roots do match is when a equals -2. So you can use graphical reasoning when you solve equations, and that's very important. I mean, there's not so many questions in, well, there's no questions in GCSE where you need to use this method, but we're not doing GCSE, we're doing exciting maths. Hopefully, hopefully exciting. Okay. That's probably the hardest question of today. Does this question make sense? Let's move on to some less demanding questions. What is the domain of the following functions? The domain means that for what values of x does the function exist, or does the function make sense? Well, you know, for example, that if you do y equals 1 over x minus 2, the function doesn't make sense if x is 2, because you can't divide by 0. If you do 1 divided by square root of x minus 2, then you have to consider only the values that give, so the square root, you cannot take the square root of a negative number. Therefore, the thing under the square root has to be positive. So here, x is not equal to 2, and x must be greater or equal to 2. So overall, x is just greater than 2. The domain is this. Okay. So that's what you need to consider. And the two functions, they look identical. They look almost like the same thing because, well, don't we know that the square root of 2 multiplied by the square root of 2 is the same as the square root of 4, which is 2. And square root of 2 times square root of 2 is 2. So it's kind of, what's the difference between them? Does anyone know what is the difference? Well, in this case, you're taking the square root of this, so this has to be greater or equal to 0. And this has to be greater or equal to 0. Whereas here, you have the whole thing has to be greater or equal to 0. What does that mean? That means this has to be positive, so this has to be plus, and this has to be plus. But here, you can either have plus, plus, or you can have minus, minus. So they're allowed to be both negative. Okay? So 3x minus 2 has to be greater or equal to 0. And the symbol for and in maths is this. And x minus 5 has to be greater or equal to 0. And that means that 3x has to be greater or equal to 2. X is greater or equal to 5, which means that x is greater or equal than 2/3, and x is greater or equal to 5. So overall, what are the possible values of x? If x has to be greater than 2/3 and it has to be greater than 5, yeah, x is greater or equal to 5. That's it. That's the domain. That's the domain of this function. Now here, it's a different story, because both of them have to be positive, or both of them have to be negative. And this is written like this. So 3x minus 2 is greater or equal to 0. X minus 5 greater or equal to 0. And, or, the square bracket is the symbol for or, 3x minus 2 is less than or equal to 0, and x minus 5 is less than or equal to 0. So either they're both positive or both negative, because if they're both negative, if both brackets are negative, then the multiplication is positive, and that is allowed. You're allowed to take the square root of a product of two negative numbers. Makes perfect sense. And then, therefore, we already know that this means x greater or equal to 5. We've already solved that. Now this one means x is less than or equal to 2/3, and x is less than or equal to 5. So if x is less than or equal to 2/3 and x is less than 5, then what? If it has to be at the same time, it has to be less than 2/3 and less than 5. No? Where did I lose you? Did I lose you somewhere on the way? Less than 2/3, less than or equal to 2/3. All right. Which part would you like me to go through again if I've confused you? So in order for this thing to exist, okay. Oh, I see. I see. Both brackets have to be positive, or both of them have to be negative. And therefore, the domain of this function, domain, is x is greater or equal to 5, or x is less than or equal to 2/3. In maths, we would write that as this: x belongs to the set from minus infinity to 2/3, square bracket, because including 2/3, union from 5 to plus infinity. So this is a set notation. Set notation. X belongs to the set of numbers from minus infinity to 2/3, union with 5 to plus infinity. Here, you would write in set notation, x belongs to the set from 5 to plus infinity. You don't have to use set notation, but it helps if you're familiar with it. So yeah, and let's draw these two functions just to see what are we dealing with. So good old Desmos. Y is equal to square root x minus 5 square root 2x minus 3. Is it 3x minus 2? 3x minus 2. 3x minus 2. X minus 5, 3x minus 2. X minus 5, 3x minus 2. Okay. Well, it's a graph that looks like this. Interestingly, looks like a straight line. It is. It sort of is, but it's a graph like this. But you do the same thing but with just one root. Aha, here it is. So you can see that this graph exists on the left and on the right, whereas this graph only exists on the right. But as you can see on the right, these two graphs match up. So this is the separate one where x minus 5, 3x minus 2. And this is the second graph. You don't really need to understand the shape of that graph. I mean, it would help. It would be great if you could, but don't worry if you don't. The point is that when we talk about the domain, we are asking what are the possible values of x. And in the okay. My favorite exercise probably is sketching graphs. And these are lovely graphs. So I'm sure you will enjoy sketching them with me. The principle is the same. You remember what the modulus means, and then you draw 3 different graphs. Okay. So let's have a look. It's modulus x minus 5 plus modulus x minus 2. Well, we know that x minus 5 is equal to x minus 5 if x minus 5 is greater or equal to 0, because that's the definition of the modulus. Okay. That means if it's a positive number, you just don't touch it. X minus 5 greater than 0. That's same thing as saying x is greater than 5, isn't it? Right? Because I mean x minus 5 is greater than 0 if x is greater than 5. And it's equal to minus x plus 5 if x minus 5 is less than 0, or in other words, x is less than 5. So this thing is equal to this if x is greater than 5, and it's equal to minus x plus 5 if it's that. Now, x minus 2 is x minus 2 if x is greater than 2. and it's equal to minus x plus 2 if x is less than 2. Now, you would think that there are 4 possibilities. There are 4 possibilities. Actually, there are 3. There are 3 possibilities. So there's x. This is 2. This is 5. If x is less than 2, it's also less than 5. So this is x then less than 5. X is less than 2. Between 2 and 5, x is obviously less than 5, but it is greater or equal to 2. And if it's greater than 5, and is greater than 5, and x is greater than 2. It's not possible for it to be less than 5 and more than 2. That doesn't happen. Okay, so less than 2 and more than 5 is not possible. Okay, so we don't consider that. So we have 1, 2, and 3. All right. So in the first case, if both of them are negative, then y is, if both of them are negative, that means x minus x plus 5 minus 2, more minus x plus 2. So that means that y is equal to minus 2x plus 7. So between minus infinity and 2, the graph looks like this. Now for this case, y is equal to, it's less than 5, so it's minus x plus 5 plus x minus 2. And that simplifies to y equals 3. Finally, if both of them are positive, then it's just y equals x minus 5 plus x minus 2, which is y equals 2x minus 7. So if x, so we just draw 3 graphs. Two and 5. 2, 1, 2, 1, 2, 5. 2. So when x is less than 2, it's minus 2x plus 7. Plus 7, 1, 2, 3, 1, 1, 2, 3. So it goes through this point. And the gradient is minus 2. It's a straight line that goes like this. Now, if x is between 2 and 5, it's equal to 3. So it's a horizontal line. And if x is greater than 5, then it passes through 1, 2, 3, 4, 5, 6, 7 with a gradient of 2. So this is the graph of this function. It has 3 separate sections, depending on how the modulus is opened. Does that make sense? I'd like to see 5 answers, please. I will pick on you if you don't reply. Bencat, Mark, what do you think? Yep. Mark? Okay. Right. So, this is how you would draw this graph. Now, this looks very scary. Does anyone notice anything special about it? Anything special? It is a quadratic, yes. Something more special. Multiples of 4. Well, true. But what else? True, but last numbers are squares. Yes, you're getting closer. Not just the last numbers are squares, but they are complete squares. Well done. They are all complete squares. So let's complete them. Let's write them as complete squares. Square root of x minus 2 squared plus square root of x minus 4 squared plus square root of x minus 6 squared. Now, one thing that you need to remember, and actually that's one of the definitions of the modulus, is that the square root of a squared is equal to modulus a. If you think about it, it has to be true. Because you are not allowed negative numbers under the square root, but because you're squaring it, right? Because you're squaring it, then you don't care about the minus. And the same with the modulus. The modulus just removes the so you could say by definition, maybe. Okay, so this means that this graph becomes x minus 2 plus x minus 4 plus x minus 6. And we already know what to do with this because we know that there are 3 breaking points on this graph. We have, if this is x, this is 2, this is 4, and this is 6. We know that the graph breaks 3 times. So here, they're all positive. So y is equal to x minus, sorry, they're all negative. So it's going to be minus x plus 2, minus x plus 4, and minus x plus 6, which is minus 3x plus 12. So y is minus 3x plus 12. Here, y, so 2 is positive and these are negative. So y is 2x minus 2 minus x plus 4 minus x plus 6, which is y is, this cancels, 2, 8 minus x plus 8. Now, if it's greater than 4, then these two are positive, this one is negative. So y is x minus 2 plus x minus 4 minus x plus 6, which gives us x, x, just y equals x. Oh, that's cool. That's massively cool. And finally, we have all positive, so 3x minus 12. Beautiful. So what we need to do is to draw the graph. So 1, 2, 3, 4, 5, 6, 7, 8. There's 6, that's 2, 4, 6. Okay, minus 3x plus 12. Well, that's a bit nasty. 1, 2, 3, 4, 5, 6, 7, 10, 11, 12. And with a gradient 2, 3, 2, 3, 1, 2, 3, 1, 2, 3. The gradient of 3, bam, bam, bam. So the graph is like this. Then it goes minus 1, like this. Then it goes y equals x, so it goes like this. And then with a gradient of 3. So this is the graph. Okay. Do you think you would be able to do, like, if you close everything and I give you this task, do you think you can do this right now? This exact same task? Yes or no? You think you could draw the same graph if I right now? Joe, that's great. Yeah. What about the rest of you? Okay. And now we're getting to some really interesting graphs. Okay. Modulus of x minus 1 divided by x minus 1. What is this? What on earth is this? Can somebody try to draw it, maybe? Actually, you can use a pen if you wish, or just tell me what it is, what it's going to be. You can test it for different values of x. Maybe just use a table. Okay, fill in a table, x and y, and I don't know, take minus 3, minus 2, minus 1, 0, 1, 2, 3. Okay, if x is minus 3, what is going to be? Ooh, very good. So if x is minus 3, what is y? You don't have to use this method. I think Ikshita, you got it. You got the it's going to be -1. So how does the graph look like? I'll give you a few more minutes. Ooh, yes, they are two lines that never touch. Absolutely. Two horizontal lines. Not, well, they are parallel technically. Yeah. So if you substitute the values, it's going to be -1, -1, -1, -1. At 1, it doesn't exist because you can't divide by 0. But there's going to be 1, 1, 1, etc. So it's going to be really simple. It has to be. So until 1, it's going to be like this, and then like this. This is the graph. So this is x, this is y, this is 1, this is -1, this is 1, this is 0. It doesn't exist at point, so we would draw it like this. It doesn't exist at 1. So, so yeah, this is the graph. And if you do it in Desmos, y is equal to -1, x -1. Here it is. And if you try to go here, it's 1, undefined. And the same thing here, 1 undefined. Because you can't divide by 0. It's quite cool, right? And if you think about it, it has to be like that because modulus x -1 is x -1 if x is greater than 1, and it's minus x plus 1 if x is less than 1. Therefore, y, which is modulus x -1 over x -1, is either x -1 over x -1 if x is greater than 1, or it's minus x plus 1 over x -1 if x is less than 1, which is the same thing as saying it's 1 if x is greater or equal to 1. Well, equal doesn't make sense because it can't be equal to 1. So we have to reduce that to just greater than 1. And it's equal to -1 if x is less than 1. That's it. That's the graph. And this graph, That's an interesting one. So it's the same thing. It's the same idea. You know what? I'll leave it to you. I'll leave it to you. Try to figure it out for yourself. Figure by yourself. And finally, this one. This is a nice one. So this is incredibly hard to do from the definition of modulus. But what you can do here is using transformations. So you start with y equals modulus x. Y equals modulus x is a graph that looks like this. X, y. So it's a graph that looks like this. So here it is. Y equals modulus x. Here it is. This is the graph. Now then you do y equals modulus x minus 2. That is a vertical shift. That is a shift by down by 2. So the graph becomes like this. And if you draw it, minus 2. Minus 2, it's a vertical shift, okay? Now, then there's a modulus. So modulus y equals modulus x minus 2. Now, what does the modulus do? Can somebody say? Can somebody switch on the microphone and tell me what does the modulus do? In simple words, like if I was asking a kindergartner or somebody from the nursery. Kindergarten is more like German. Kindergarten. What does the modulus do? It makes negative things positive, right? This is the simple answer. What is the modulus? The modulus makes negative things positive. And the negative things on this graph are just here. This is the negative things. We make them positive. So literally, we make them positive. So this transformation makes negative into positive. And we're talking about the y's. So what this transformation does is well, it's very satisfactory. You will study this in depth in well, in depth-ish. You will study that at late level. So this is minus 2. This is minus 2. So it used to be like this, but as I said, we make negative things positive, so it goes like this. And the positive remains positive. So now the graph looks like this. So it's quite cool. This is 2. Okay. Do you understand the transformation? Do you understand what it does? It turns negative things, it just flips it. It makes it positive. It's just like magic. So the modulus. And then finally, no, not finally, there's one more transformation. We do minus 1 now. It's another vertical displacement. So y equals modulus x minus 2 minus 1. So it's a shift down by 1. Okay, so that gets even more cooler. So it's now 1, 1, 1, 1, 1, 1. So it's shift down by 1. So that's 1, 2, 3. Minus 1, minus 2, minus 3. That's 1. And then finally, we do the modulus. So once again, we turn the negative minus 2, minus 1, and then another modulus here. We turn negative becomes positive. So we take the same thing. We take the same thing. In all the negative parts, we flip into the positive, onto the positive side. No, sorry. Bam, bam, bam. So it goes like this. Now it used to go down and up. Now it goes up and then down, up and then down, up and then down, up. This is the graph. This is the graph of y equals modulus, 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 x modulus minus 2 modulus minus 1 modulus. I don't know. Type C if you find it cool. If you think it's cool. No C's. That's fine. Let's have a look. Let's have a look at so modulus x minus 2. Then you introduce a modulus around, and you can see that becomes this. And then you do minus 1. Now it's like this. And then you introduce another modulus. And this is your graph. You could continue. You could do minus 0.5. And then another modulus. Okay. Right. So I hope you found it useful, or at least interesting. And yeah, see you in a week's time. Welcome.